Hi everybody, I am Vinod. Uh, Today we are going to discuss metrology and inspection. So metrology and inspection is also called metrology. So weightage of this topic in GATE is 1 to 2 marks. Out of 100 marks, 1 to 2 marks in GATE you will get mostly 1 mark question. Sometimes they ask 2 marks questions, 1 2 mark question. Major important topics are limits, fits, tolerance, and linear and angular measurements. Next is gauge design. These are the important topics here. So almost 90% of the time question will come from limits, fits, tolerance. So remaining topics are almost theory. They never asked any question. So first we start with limits, fits, and tolerance. So what is limit? Limit for any manufacturing component there must be upper limit and lower limit. So these are called limit. Two extreme permissible sizes is called limit. Two extreme permissible sizes is called limit. There are lower limit and higher upper limit. Two types, upper limit and lower limit. Upper limit is the maximum it can go up to, and lower limit is the minimum limit. Similarly, fit. What is fit? Fit is a relation between two parts. The relation between two parts. Relation between two parts. So it may be clearance fit, interference fit, or transition fit, any type of fit. Anyway, we will discuss all those things. Tolerance. So what is tolerance? Tolerance is permissible variation in dimension of a part. It may be either hole or shaft. So suppose, for example, if I want to manufacture a bolt of diameter 10 mm, if I want to manufacture a quantity of 1 million, I can't manufacture all million components of 10 mm. So I will give a tolerance range. So it is 9.95 mm to 10.05 mm. So in this range my component has to be, diameter has to be there. So because we can't manufacture exact dimension, there is little tolerance you will give. So permissible variation. Permissible variation in dimension of a part. is called tolerance. It also you can measure by tolerance is measured by it is a difference between upper limit and lower limit. Upper limit and lower limit of a component. If you want to find the tolerance of a bolt, so you have to differentiate between you have to calculate the difference between upper limit and lower limit. Next is alliance. What is alliance? Difference between two mating parts is alliance. Difference between two mating parts is alliance. Suppose if I insert a nut bolt into the nut, so the difference between the gap is called alliance. Instead of nut and bolt, if I insert the pen into the cap, then it is transition fit, where it fits exactly. Similarly, alliance is positive alliance, there negative, it may be negative alliance. So positive alliance is called clearance. So negative alliance, similarly negative alliance is called interference. So it happens in interference fit. Interference fit means the fit is you need external force. So this is alliance, positive alliance and negative alliance. So how to calculate it? Alliance equal to lower limit of hole minus higher limit of shaft, if it is positive alliance. Lower limit of hole minus higher limit of shaft. Anyway, we discuss it clearly once we start the clearance fit, interference fit and transition fits individually. So next is deviation. So deviation is difference between limit of a component and basic size. Difference between limit of a component and basic size. So what is basic size? Basic size is also called as nominal size. It is standard size with reference to which the limits of variation of a component are measured. So if you calculate the diameter of a shaft to withstand some certain speed, then you will get 44.5 mm diameter, but that is actual size. So actual size is design, based on design value, and basic size is, because 44.95 you won't get in design. So sorry, basic size is integer values like 45, 40, like that. So plus or minus you will add allowance for that, tolerance, sorry. So basic size is standard size. Basic size is standard size of a component basic size is a standard size of a component with reference to which the limits of variation are determined. With reference to which the limits of variation are determined. It's also called nominal size. So as we discussed in deviation, so there is upper deviation and lower deviation. What is upper deviation? Upper deviation is difference between upper limit and basic size. Similarly, lower deviation. Lower deviation is difference between lower limit minus basic size. There is fundamental deviation. So fundamental deviation is whichever is minimum, fundamental deviation or standard deviation, whichever is minimum of upper or lower deviation is called fundamental deviation. Minimum of upper and lower deviation is fundamental deviation. Next is topic is unilateral system. Unilateral system. The dimension of a part is allowed to vary only on one side of the basic size. Then it is called unilateral system. So this is basic size line. Suppose for example it is 50 and this one is 0.05. So this is tolerance. It can be represented as (50) plus 0.05 plus 0.00. So the tolerance, the dimension is varying only in upper side, only in one direction. So that's why it is called unilateral system. So the dimension of a component, the dimension of a component is allowed to vary only on one side of basic size, only on one side of basic size. It is called unilateral system. Similarly, bilateral system. So if the dimension is allowed to vary on both sides of the basic size, then it is called bilateral system. Dimension of a component varies on both sides of basic size. So for example, same example we will take. This one is 0.05, this one minus 0.05. So this component is represented as 50 plus 0.05 minus 0.05. So the total tolerance is 0.1 mm. So 50, this shaft or whatever component is varying from 50 minus 0.05 to 50 plus 0.05. That's why this variation is in positive side as well as a negative side of the basic size. That's why it is called bilateral system. Basic shaft. The shaft whose upper deviation is 0 is called basic shaft. Whose upper deviation is 0 is called basic shaft. If you take the same example, shaft upper deviation, so this is 50 minus 0.05, so upper deviation equal to, this shaft is represented as 50 plus 0.00 minus 0.05. So upper deviation is 0 because it is upper limit is same as the basic size. Upper deviation equal to upper limit minus basic size. Upper limit is same as basic size, so upper deviation is 0. It is called basic shaft. Similarly, basic hole. Basic hole is same as the, for basic hole you need to have lower deviation has to be 0, then that is called basic hole. Hole having lower deviation 0 is called basic hole. Same example which we have discussed. .05, this 50 is basic size. It's represented as 50 plus 0.05, 0.00. Basic hole where lower deviation is 0. So here if you want to calculate lower deviation of hole, lower deviation formula equal to lower limit minus basic size equal to 0. That's why it is called basic hole. According to manufacturer, there are two types. One is hole basis system, another one is shaft basis system. Hole basis system. In hole basis system, hole is manufactured first. Then shaft size varies according to the requirement of the fit. According to the required fit. So it is hole based system. Next, shaft based system. Shaft is manufactured first. Then hole dimension varies. Out of this, hole basis system is easy and it is application wise it is mostly they use hole basis system only, because shaft it's easy. If once you manufactured hole, then accordingly you can change the size of the shaft. That's why it is, is hole based system is more in practical usage. This is about fundamentals of limits fits, and then we start with types of fits. There are three types of fits. One is clearance fit, another one is interference fit, next one is transition fit. So transition fit may be either clearance or interference depending upon the alliance between the two parts. So before going to each one of these, some notations we need to remember is holes are represented by capital letters. Example, H, G, K, like that. Shafts are represented by small letters. Standard notation, everywhere same notation they use. Small letters. Example, small h, small g, small k. So clearance fit. The clearance fit is formed when the lower limit of the hole is greater than the upper limit of shaft. Clearance fit the basic and necessary condition is lower limit of hole is less than upper limit of shaft. Tolerance for shaft and tolerance for hole.